First thing that we are looking at is the idea of something called a scatter diagram or a scatter plot. And what a scatter plot is, it's a graph, but it's a graph of your data. And like here is a data set. That is very easy to collect. You know, you could have, you could be standing out here in the corner of Dobson and Southern and count the red light runners, you know, 10 o'clock to 11 o'clock, how many people ran the red light. 11 o'clock to 12 o'clock, how many people ran the red light. So that, very, very easy to do. And then you can use that, which we're going to do, to create something called a mathematical model, so that knowing what's happened in the past, you're going to try to use it to predict what's going to happen in the future. That's what it's all about. That's what you want to do. You want to be able to make predictions. In business, it's extremely important to make predictions, because you need to know very far ahead how much materials you're going to need to order, how many people you're going to need to have working in order to keep them busy. Because you don't want to be in a position where you produce too much or you have a run on it, people want it and you can't produce it enough. Then you lose business because of that. So it cuts both directions. You've got to use the resources that you have. So trying to get a mathematical model ends up being extremely important. When I was at ASU and I was director of the Learning Center there, what we did was essentially our courses were intermediate algebra, college algebra, and trigonometry. That was what was in my area. And then you had all the other math courses above it. Our department chair was one of the first that started. He had to figure out how many of each section of classes to offer, because there's nothing worse than you guys trying to sign up for classes and there are not any. They're all closed already. Or there's so many classes in one area but not enough in the other. So he began to take data. You have to run it fall to fall and spring to spring, because the fall to fall is a different enrollment than spring does. It just does. Enrollment drops for spring, so you've got to compare springs, you've got to compare falls. So he went over a period of time, looked at the fall, ran and came up with an equation that he could use to predict the number of classes given the trend, how many intermediate algebras did he have to offer, how many college algebras have to offer, how many calculuses did he need to offer, to make sure he would have a maximum number of classes, if possible, available for students to take. There was nothing wrong worse than having to shift schedule where you have to cancel a class, then you have to add one. And what do you do with the students who were already there for the class you canceled? And then you have to make sure that you're going to have enough students to fill the one that you've just opened. That's the problem we have around here, especially when the direction we've gone with the success from day one, is that they try to maximize the courses. So it's easy to gather data. I mean, that's an easy thing to get. And what you do with the data then is you graph it. And when you graph it, what you then try to surmise is it a straight line? And if I look at this, and essentially what you do, you could either do in your head or kind of do a line graph if you connect the dots. And you would look at that. That's not a straight line. So that says that's really not a linear function. Now, if I omit that one point, it might be closer to being linear, but it's still not linear. And so you then try to surmise, if I were going to do a mathematical model, and by the way, our calculators do linear models, quadratic models, linear y equals mx plus b, quadratic y equals ax squared plus bx plus c, cubic models. Our calculators do logarithmic models. They do exponential models, and we don't do it but they do a trigonometric model as well. So many kind of models, and you look to see what's the shape of that graph, and can I get a function, right, that looks like it'll go through those dots. If it does, then that means I can use this to predict what's going to happen next if the trend continues. Okay. So what a scatter plot is just a set of dots that essentially is your T-bar chart in visual form. You don't connect them. You may connect them visually, but a scatter plot you don't automatically connect. This is essentially another example. The dots are basically the data, and essentially what they look to do is to fit a straight line through the data. And they said, well, you know, the data is clustered on either side of a straight line. So you've got as much above as you do below. So if you're looking at error, it's kind of going through the middle of it. Essentially, this line right here is called a regression line. And that's one of the things we're going to be finding. What is it? It's just y equals mx plus b. It's our furry friend, the straight line. And our calculators have the ability, if we were to put in those data points, to come out and give me the equation for that line. To give me the equation for that line. And so for us, that's called a regression line. And what we're going to do is called a linear regression. A linear regression. A linear regression. A linear regression produces a regression line.